This is lesson 10-7, interpret graphical displays. So we've been learning about some of these displays that we can use when we're dealing with statistics, and we're going to revisit those a little bit more in depth in one lesson here. So we're going to look at dot plots and histograms and box plots or box and whisker plots. And instead of learning how to create them, we're going to look at how to kind of read them and analyze them. So let's start with dot plots. Interpret dot plots. The distribution of a set of data shows the arrangement of data values. So the distribution means like the spread or like the way that the data is. It can be described by its center, like the mean or the median or whatever's in the middle, the spread or the variation, or the overall shape. Determining the symmetry of a distribution is one way to describe its shape. If the left side of a distribution looks like the right side, then the distribution is a symmetric distribution. If there is an outlier, the distribution is usually not symmetric. So symmetric means it's kind of the same or very close to the same on both sides. So we're going to look at these examples here. So in these two dot plots, on the left here we have a symmetric dot plot because, as you can see, it's like 2, 3, 4, and then if you go from this way, it's 2, 3, 4. It just makes this shape that if you put a mirror in the middle, it would look the same. This is symmetric because the left side looks like the right side. Over here, this is a very obviously not symmetric dot plot because the left and the right sides do not match here. If we split that straight down the middle, you'll see that we have different situations happening on the left side and the right side. So symmetric, it doesn't have to be like perfectly perfect. It can be like almost symmetric and we can still consider that to be symmetric. But it's definitely not symmetric if it is not even close. So why will the mean and median for a symmetric graph always be the same value? If it is perfectly symmetric like this, our median is going to be in the middle and our mean is going to be exactly in the middle. So there won't be any room for a little decimal or like a one higher, one lower. If it's exactly perfectly symmetrical, those means and medians will match. The shape of the data distribution tells you which measure of center and measures of spread are most appropriate to use. So this is kind of similar to when we were looking at outliers and determining whether or not we should use the mean or the median. You can do this based on the symmetry of the data distribution as well. So if the data distribution is symmetric, you should use the mean to describe the center and use the mean absolute deviation to describe the spread. If it is not symmetric, then you should use the median to describe the center and use the IQR to describe the spread. This is similar to the same reason why you wouldn't want to use the mean when there's an outlier. If there's something non-symmetrical, including an outlier, but not necessarily, it's going to shift the mean in a weird direction and make the data, like it'll misrepresent the data. So the median is better to use when there is not a symmetric situation happening. So example 1, interpret dot plots. Loading. All right. The result of a class survey about the number of states visited by students are shown in the dot plot. Choose the appropriate measure of center and variation, then use the measures to describe the distribution. So here is our dot plot. We've got a range here of all the way from 0 up to 9. And there's some dots here, there's not some dots here. What do you notice about the shape of the distribution? Well, I can kind of tell just from looking at this. This is not symmetrical, though if we just looked over here, it's kind of close, but it's not exactly symmetrical. So let's choose the appropriate measure for this particular dot plot. Is the data evenly distributed between the left side and the right side? No, it's not. There's way more data over here on the left than there is on the right. So we're going to say no. And then we're going to hit that. So, okay, wow, they're making me scroll like crazy here. All right, is there an outlier? Well, just from looking at it, I'm going to say probably this 9 is an outlier. If you wanted to actually go ahead and calculate that, you could, but from this, like, that is so far over here by itself, I'm going to say, yeah, probably that's an outlier. It's okay to eyeball that sometimes, especially when it's that extreme. So the data is therefore not symmetric. We knew that already just from looking at the graph. So if the data is not symmetric, we should use the median and the interquartile range to describe the measure of variation. So that is how you interpret the dot plot like that. And then we want to describe the distribution. So we can do some things like this. How many students responded to the survey? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. The median is, well, where is the median here? We can find the median by doing that thing where we count. You have to include the outlier. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The median is going to be 2 states. This indicates that the median of states visited by students can be summarized by the single value of 2 states. The interquartile range is 3 minus 1, or also 2 states. This indicates that the spread of the data around the center is about 2 states. Other than the outlier, there is not a lot of variation among the data. So it's saying that, like, if most people were 2 or like pretty close to 2. All right. Blah, blah, blah. Try it for the dot plot. If you need some help describing your distribution, you can go back and look at the example and see what kind of questions they are asking about it and answer the similar questions for your check dot plot. We're going to move on to interpreting histograms eventually when this loads. Are you going to load? It's going to glitch out on me right now. I love that. Okay, hang on. Okay, it's back. All right, interpret histograms. You can also describe the distribution of histograms using symmetry, but also we have some other vocab words here for us: clusters, gaps, and peaks. A cluster occurs when data values are grouped together. That's what a cluster is in math and in just not outside of math. A gap occurs where there are no data values. So like this is a gap right here. And then a peak is the most frequently occurring value or interval of values in the data set. So that's going to be like the highest bar that you have. Data were collected on the heights of some buildings in Seattle, Washington, and is displayed in the histogram. Select each button. Blah, blah, blah. Okay, so we're going to look at what we've got here. We need to find our peak. The peak is this highest bar, which is the 400 to 499 range. Our gap, we have one gap in this particular example, and that gap is from 800 to 899. And then we have a cluster from 400 to 799. So it's all 4 of these bars are clustered together. So that starts at 400 and it ends at 799. So that's how we can look at the histogram. Okay. Let's look at one more. Eventually. Wow, it's being super slow today. All right, here's a new histogram about solar eclipses. It shows the duration in minutes and seconds of solar eclipses over a 10-year period. Use clusters, gaps, peaks, outliers, and symmetry to describe the shape of the distribution. So we can see right away we have peak, we have gap, we have cluster. We might have an outlier. Let's look. Identify any symmetry, clusters, and outliers. So the symmetry works the same way in a histogram as it does with a dot plot. So if it's the same on the left side as it is on the right side, then it is symmetric. That is not the case with this particular histogram, so we're going to say no, it is not symmetric. It's much heavier on the left side. Are there any clusters? Yes, there is a cluster. There's some bars right here. There is a cluster from 0 point, like so 1 second to 7 minutes and 30 seconds is the end of that cluster there. Are there any outliers? It's possible that this is an outlier over here, though it did happen twice. So if it is an outlier, then it's actually 2 outliers. So let's see if they call this an outlier. No, yeah, okay. So that's not considered an outlier. That's probably because it happened twice. So again, when you are looking at this, you can determine that using the outlier formula. What happened? Oh, there's nothing there. Okay, so those are the kind of questions we want to look at here. Where is our peak? We do have a highest bar here, so we could say yes, there is a peak. That peak, there's only one. Sometimes you have more than one. In this case, we only have the one. And it is from 1 second to the end of 2 minutes and 30 seconds. Do we have gaps? Yes, we do have a gap. This break doesn't count as a gap because there is no data before that. So we're only going to count this one gap over here. There's just the one. And it is from 7:31 to 10 minutes. And then you can describe the distribution. So we can say something like the data is not symmetric, it does not contain any outliers, the data cluster around 1 second to 7 minutes and 30 seconds, and they have a peak from 1 second. So basically you're just saying in words here what you determined. So yes, there was a gap, so you just say in a sentence what that gap was. You could say that it's not symmetric, you could say there's no outliers. So you're kind of just saying that in words. So what can you infer about solar eclipses? We're not going to do that. Try this for the histogram. I do recommend when you check for outliers, if it's not blatantly obvious, you should probably go through and actually calculate that out. And then finally, we're going to learn to interpret box plots eventually after she loads here. Can you load faster, McGraw-Hill, please? Okay. Okay, literally every time I go to pause the recording while I wait for it to load, it loads right away. So anyway, interpret box plots. Although a box plot does not show individual data values, you can still describe the distribution of the data. Box plots are constructed using the median and interquartile range, so use those measures to describe the center and variation of the data. Because a box plot does not show individual data values, the mean cannot be found unless the data are perfectly symmetric. If they are, then the mean and the median will have the same value. So here's what it would look like if it were symmetric. We would have our median right in the middle, and then we'd have an equal distance between the median and each quartile, and then our whiskers are going to be like equivalently lengthed based on the IQR. So if the whiskers are the same length, the median line segment divides the box into two equal sized boxes, then the distribution is symmetric. So it's exactly in the middle, same size box on each side, same size whisker on each side. So on the other hand, it's not symmetric if we have our boxes are not the same size or the whiskers are not the same size. If the boxes are the same size and the whiskers aren't, it's still not symmetric. Or the other way around. If the whiskers are the same size but the boxes aren't, and maybe I just said the same thing twice, I can't remember. Basically, it's not symmetric unless both are the same size. So if you have mismatched box, not symmetric. Mismatched whiskers, not symmetric. Only symmetric if same, same. Okay, the whiskers don't have to be the same length as the boxes, they have to be the same length as each other. And then an outlier, when you have a box plot and you are going to put an outlier on your box plot, you actually don't include it in the box and the whiskers. You kind of just put it over here as an asterisk. So if you ever are plotting a box plot with data that has an outlier, you can still include your outlier. It's much, much easier to tell if there's an outlier from a box plot because it's represented like this. It's not even connected to the rest. Okay, and so that would also be considered not symmetric exactly because of this outlier over here. Okay. One more example here. Thank you for loading this time. Here is a box plot about fitness club attendance daily. We're going to describe the distribution of the data, including any symmetry outliers, measures of center, and measures of variation. The measures of center being median, and measures of variation would be the quartile and interquartile range. So we've got our box plot here. sort of. There's supposed to be a title there. For some reason, there's not. The median is there at 70. That's always that middle line inside the box. Symmetry. Well, the whiskers are the same length, but the boxes are not the same size, and we have an outlier over here. So the median segment does not divide the box into two equal boxes, so the distribution is not symmetric. We do have an outlier. It's represented by the asterisk. And our IQR, we can tell from the outer edges of our box, that would be quartile 3 is 80, quartile 1 is 65, so 80 minus 65 is 15. And so that means that the middle 50% of the data vary by 15. And so, again, with the shape here, you can tell that it's not symmetric. So do the check. And again, if you forget what kinds of things to say or what kinds of things to include in your description or your interpretation, you should go back to the example and see what little things they decided to mention. But mostly it's going to be like the median, the symmetry, the interquartile range, is there an outlier or not, just those kinds of questions. And that is the end of that lesson and also the end of our module. So get ready for the test coming up. We will do some review and hopefully you will be successful.